Welcome back to Cosmic Galaxy. In this video, we're discussing, do black holes explode? Make sure to like the video, subscribe to the channel, and hit the bell icon. Black holes are cosmic vacuum cleaners, massive objects from which no light can escape. Most people believe that black holes do nothing but sit there and devour stray bits of gas or dust. But do black holes have more interesting interior lives? Could they, for example, explode? The answer is unequivocally yes, if an explosion is defined as a sudden brief release of tremendous amounts of energy. The best part is that they can explode in a variety of interesting ways, either by detonating themselves or their surroundings. Hawking radiation. There is only one way for black holes to explode. The process is related to the fact that black holes aren't completely black, which was discovered in 1976 by famed astrophysicist Stephen Hawking. Nothing can come out of the black hole in classical physics, Samir Mathur, a physicist at the Ohio State University, told Live Science in an email. However, Hawking discovered that using quantum mechanics, the hole gradually leaks away its energy to infinity by emitting low-energy radiation, which is known as Hawking radiation. A black hole will gradually lose mass as it emits Hawking radiation as long as it is not sucking in new material. Hawking radiation, on the other hand, emits slowly. Every year, a normal black hole with a mass a few times that of the Sun emits about 1 photon, or packet of light. At that rate, it would take 10,100 years for a typical black hole to completely evaporate. However, Hawking discovered that smaller black holes evaporate much faster. As a black hole shrinks in size, it emits more and more radiation. The black hole emits so much radiation in its final moments that it effectively acts like a bomb, releasing a torrent of high-energy radiation and particles. If small black holes, about the size of Earth, formed in the very early universe, it would take billions of years for them to evaporate, implying that these primordial black holes, if they exist, would be exploding all over the universe right now. Astronomers have yet to discover evidence of exploding primordial black holes, but they may exist. Superradiance. Because black holes spin, they produce a unique type of explosion found nowhere else in the universe. Rotating black holes, also known as Kerr black holes after New Zealand mathematician Roy Kerr, who discovered how they work, produce an ergosphere around their event horizons. An ergosphere is a long region of space in which nothing can remain still. As soon as a particle enters the ergosphere, it begins to orbit around the spinning black hole. Photons can be drawn in by the rotating spacetime around a black hole. Photons can bounce off each other or any wandering particles, if there are enough of them. Occasionally, the bouncing causes photons to escape the ergosphere. However, sometimes the bouncing causes photons to fall deeper into the black hole, where they gain energy. They can then be scattered to a higher orbit before falling back down. The photon gains energy with each repetition of the process and each trip around the black hole. This is known as superradiance. When the photon finally breaks free, it will have a massive amount of energy compared to when it began its journey. If there are enough photons involved in the process, they can all burst out at once with incredible energy, forming what is known as a black hole bomb. Even though the black hole does not explode, this superradiant effect demonstrates how powerfully black holes can affect their surroundings. Disks and jets. The most common way that black holes cause explosions is not through self-destruction, but rather through the sheer power of their immense gravitational force. Supermassive black holes reside in the centers of galaxies, and large clumps of matters, such as stars, occasionally pass too close. When this happens, tidal effects tear the stars to shreds, releasing an explosive burst of energy in the process. This release of energy is visible to Earth's astronomers as a brief but intense flare of X-ray and gamma-ray radiation. Thank you for watching the video.